Yes, good evening to you all once again. This is Srinivas going to explain a simple example on to find out the transfer function of a given block diagram using the block diagram reduction rules. In our previous session or in our last lecture, we have seen very important rules that are to be applied or that are to be implement for the given block diagram reduction in order to find out the transfer function of a given block diagram. Okay, you always remember that the transfer function is nothing but you simply have to find out the ratio of output to the input, that is C of S by R of S. So by the way, so today I am going to start the lecture number 6. It is lecture number 6, in which I am going to explain one example. We will see one example on finding of, it is transfer function, finding of transfer function using block diagram reduction rules. Okay, in last lecture we have seen few rules. So in this lecture we will see one example. I will explain you. So let us see. In this example we have a summer point followed to, this is G1, and then this is G2, and then it is another summing point. This is your C of S, and then it is your R of S, and then here you have given one feedback element as H. So this is given like this, and then from before this block you have one more gain, as we have G1, G2, then you can take it as G3, and you are giving to this summer point, this is plus, this is also however going to plus, and here it is minus. Input is always plus. This is the given problem. Carefully see this problem, in which your problem is find out the transfer function that is equal to C of S by R of S. This is what your question. You have to find out C of S by R of S. This is your problem in this. Okay, fine. If you see this problem, so we can solve this problem in steps, in few steps. Step 1, after that step 2, and then after that step 3, like that. So if you carefully see this problem, this is your input signal, this is a summer point, and here one point, if you are able to see now, this point is called as takeoff point. This point as well as this point, these are called takeoff points. Okay, these are called takeoff points. For your understanding, I am writing, this is one takeoff point, this is also another takeoff point. These are called takeoff points. Similarly, this is summer, this is also summer. This is normally you will have at the input stage, and this is at the output stage. Now if you see the problem now, so you have to simplify in such a way that you should have one loop, closed loop. So see carefully, if you see here, this is input signal and this is the gain is there, this is the gain of this path, and here one takeoff point is there. Here you are having some loop. So if assume that if you don't have this takeoff point here, if you don't have this takeoff point, otherwise if you don't have this connection here, because this connection it is going like this, no, through G3 it is going to this summer. Assume that you don't have the connection here, then simply you have direct this one. It is a closed loop feedback, as you have studied in our second lecture or in the second session of our class. So if you don't have this connection, this is simply input, gain, and then closed loop. This is very easy to simplify. So then in order to bring in that simplest way, what we should do, this takeoff point should not be here. This must be shifted to the after this block, after G1. This is block, no, G1 is one block, G2 is another block, G3 is another block, okay, H is the another block. These are 1 2 3 4 blocks are there, 4 blocks are there, 2 takeoff points are there. So by simplifying these takeoff points and then blocks, by applying the rules which we have seen our previous session, we have to find out the ratio C of S by R of S. Okay, then always you should keep in your mind that, so is there any possibility of having this type of loops? Okay, then if you have that loop in between, if you have any this kind of points, then these should be shifted to either before the block or after the block. Likewise you have to think, right? In this case, as in step 1, now I am going to shift this takeoff point after the block. Okay, that is what I am going to do in step number 1. Now if you see the step number 1, okay, if you see the step number 1, I will write for you. In step number 1, what I will do, so this is, I will write as it is. This is the summer, and then you have your G1, and then you have your G2, is it not? Then you have summer, this is what your C of S, and then however this is your R of S. Okay, then this is your feedback loop. I am not at all going to change your feedback loop. I am not disturbing that. I am keeping as it is. Okay, now here if you see, this is the second takeoff point. I am not changing that because I need this, because with this takeoff point I am having a simple closed loop actually. That's why I am not disturbing this loop. Now what I am doing in step 1, I am shifting this takeoff point to after the block. I am shifting this takeoff point before the block. This point I am going to shift after the block G1 here. I am removing this entire connection. You see, this is actually, you have this connection, no? Assume that I am removed here and the block is there actually. This is what your G3, and this G3 directly it is going to here only, plus, and then plus. You see this connection, assume that I am disconnected here, this connection, and I am putting this connection to here after the block. Then you see here to here one path is there, no? This is what the path. If you shift this connection to here, there is a small modification will happen. Okay, this G3 is nothing but the gain, path gain. G1 is the gain from the summing point to this point, or otherwise if you really speak, from the summing point to takeoff point is one branch, you can say, because as you have nothing on this line, simply straight line, you have the gain as 1, if really speaking. That I will elaborately I will explain you in the next session. Okay, for your kind information and for your better understanding, now itself I am explaining you a little bit, just you listen carefully. This is the summing point, this is the takeoff point. In between these two, simply you have one simple straight line. That means that the gain of that line is 1. And from this also, from this takeoff point to this, from this takeoff point to this is the another takeoff point. In between, this is a straight line again, but the gain is g1. Here the gain is 1, here the gain is g1. Similarly, this is the takeoff point here. This takeoff point, the other end of the block is summer. So between this takeoff point and the summer, the gain of this path is g. G is the path. Similarly, here if you see from this connection, from this connection to directly here, this is the one more path. From this takeoff point to this summing point, this is another path. This is the g3 is the gain of this path actually. From takeoff point to this one, this is g3 is the gain. Now, if you shift this takeoff point to before the block, there is a slight modification will happen in this path. What is the modification? You know, the path gain 1 by g1 times path gain will be added in this path. Means as you are shifting this takeoff point to the after the block, then some amount of gain will be added in this path, that is 1 by g1. This is very important point, you should remember that. Okay, whenever you shift the takeoff point after the block, then 1 by of the gain of that block will be added, will become or will come in that path as a gain. Okay, now this means that by doing this, then you are getting, now the connection is not here. Now you have the connection here. Then you see, now the path is started from here. This is 1 by g1 is gain newly added in this loop or in this path. It is not okay, in this loop or in this path, because this is one loop here basically. Okay, not a closed loop, but you can assume it as a loop. But in this loop, 1 by g1 gain is added newly, and it is again in cascading form with g3, and then it will be added. Then if you see now, so here 1 by g1 is in series with g3. Therefore, your 1 by g1 into g3. This implies g3 by g1. g3 by g1 is the total gain of this block now. In step 2, I will solve for your simplicity. In step 2, I will show you for your understanding. Simply the same block diagram I will show you here, as you have same summing point, and then you have your g1 and you have your g, and you have your summing point. This is your C of S, is it not? This is your R of S, and here the feedback loop I am not at all disturbing, because it is very much required for us to simplify. Okay, then this is minus, this is plus. Now as I have shifted this point to here, now my block will come like this, because this 1 by g1 gain multiplied with g3, these two comes in multiplication, and this comes like this. This is plus and this is also plus. Understood? Now this is what your what is the resultant one? Then the total is g3 by g1. Simply it is g3 by g1. Simply it is, you can write g3 by g1 here. Okay, g3 by g1, g3 by g1 is coming to the summer. It is adding here. Similarly, your this is what basically your g2. This is g2. No, g2 is also coming forward. Then g3 by g1, here it is g3 by g1 plus g2. These two are adding here. Therefore, Therefore, in step 3, what I will do, these two are adding here. Therefore, you can simplify these two blocks with this. All this can be simplified here. Okay, that is one thing. And similarly, if you observe here, then here, okay, otherwise in detail I will write in step number 3 so that you will understand clearly. In step number 3, I will write for your better understanding. Step number 3. So again, just little bit clearly I will write. So this is your G1. This is one point, no? That point you can write here also like this. Don't worry. This is G2. This is summing point. This is your C of S. This is your R of S. And here, this is, however, you have your feedback loop as H. Okay, this is coming. And I can put like this also. This is your G3 by G1 coming here. These are the plus. Is it not? Like this also I can represent actually the takeoff points. In previous session, both that connection also I have shown here only. No, you can show like this also. Nothing wrong in that. Side by side, just nothing wrong. The meaning is same. Then you can add these two because both are additive here. This is plus, this is plus. Therefore, you can simplify this block. You can simplify this also. This is also, you know, what is this block? This much, this much. This is simply your closed loop control system, no? Minus G is the gain, H is, this is with negative feedback. So, have you remembered that in previous class, if it is a negative, then simply gain by 1 plus gain into feedback element. That is G1 by 1 plus G1 into H. That is the simplification of this. And similarly, these two will be added here. So, in the step number 4, I write for you. In step number 4, I will write for you as simply, because of this total I am simplifying, then this entire, if you simplify this, simply you can write like this. It is G1 by 1 plus G1 into H. That is the simplified version of this block, this loop. And similarly, the second one is like here. It is G2, okay, G2 plus then G3 by G1. It is G3 by G1. This is what your second block. Simplify. This is C of S. This is your R of S. Okay, these are the simplified blocks. Now you can further simplify. So here you can simplify this G1 G2. If you take the LCM, no, G1 G2 plus G3 by G1 that's all. G1 G2 plus G3 by G1, and this total multiplied by this one. Is it not? So in second step I will write for you in step number 5. In step number 5, if you write, no, it is G1 by 1 plus G1 into H. Here you take LCM, no, G1 G2 plus G3 by G1. That's all. This is C of S. This is your R of S. This is what in step number 5. Next, now finally what we have to do? This total product. This is one gain, this is another gain. Both are in series, cascading. As per our rule 1, in first rule of the block diagram reduction methods, then both gains will be multiplied. Then in the next step number 6, okay, in step number 6, step number 6, what you will do, both gains are multiplied, then you can write a total bigger one. This is your R of s, this is your C of s, multiply, that is G1 by 1 plus G1 into H, keep in a box like this. And similarly the second one, it is G1 G2 plus G3 by your G1, multiplication. So this G1 will be cancelled out, because it is this G1 in numerator, this is in denominator, both are product, therefore both will be cancelled out. Therefore what remains in step number 7, what remains, it is G1 G2 plus G3, G1 G2 plus G3 in numerator, and what is in denominator, it is simply 1 plus G1 into H. This is your R of s, this is your C of s. Therefore finally you can say that your C of s by R of s is nothing but, okay, therefore finally C of s by R of s is nothing but this much only, that is G1 G2 plus G3 by 1 plus G1 H. Understood? This is what your transfer function. This is what your transfer function. This is how you have to simplify the given transfer function using the block diagram reduction rule. Okay, thank you. We will close at this. So please, if you like this, you may like it or share to your friends, and feedback will be given so that it will be taken as highly appreciative manner, and I will improve in my subsequent sessions or lectures. Thank you very much.